Welcome to RSCH, Research Methods and Biostatistics, a 3-credit graduate course offered by Drexel University College of Nursing and Health Professions. A commonly used parametric statistic to test for significant differences between group means of two samples is the t-test. A t-test is a procedure used to compare sample means to determine if there is significant evidence to infer that the means of the corresponding population distributions also differs. The key word with the t-test is two. T-tests always compare two different means or values. There are two types of t-tests. First, there is the t-test for independent samples. This t-test is used to examine differences on means between two independent groups. Examples of t-tests for independent samples include the difference between males and females on a final exam, or, for example, the difference between scores on the American Nurses Credentialing Corporation Certification Board examinations of males and females. Second, there is the paired or dependent t-test. This t-test is used to examine differences in means between two matched or paired groups. Examples include students' depression scores after treatment A versus depression scores after treatment B. Or another example, students' scores on a quiz 1 versus the same student scores on quiz 2. In the independent t-test, one sample is taken from each of two populations. These two samples are then measured on the same variable of interest. A t-test will determine if the means of the two sample distributions differ significantly from each other. In this type of t-test, there is no overlap between membership of the two groups. An example might be the difference between means on a life satisfaction scale of married adults versus single adults, or the difference between means on the learned helplessness scale of adults with coronary artery disease versus those without coronary artery disease. This is a very commonly employed test in the health and social sciences. There are several assumptions underlying the independent t-test. First, the dependent or outcome variable is measured on the interval or ratio scale. The variable is continuous. Second, the sample means are populations are normally distributed. Third, the two samples have equal variance and means. When the null hypothesis is rejected, we assume that it is this final assumption that has been violated. What this means is that there is a statistically significant difference between the means of the two samples, and the alternate hypothesis is accepted. When using the t-test, degrees of freedom are used rather than sample size, or capital letter N, in various computations. The degrees of freedom of a statistic depends upon the number of observations and the nature of the problem. Lowercase df equals the number of observations, that is n, minus the number of algebraically independent restrictions placed upon them. Essentially, degrees of freedom, or df, is computed as follows. df equals n, that is the sample size, minus 1. Let's look at an example. The research question is, what is the effect of two different diets on weight gain of white rats? The dependent variable is weight gain. The independent variable is diet. Treatment. Diet A is given to 10 adult rats. Diet B is given to 10 adult rats. Now the t-test for independent samples would be as follows. First, you state the null hypothesis. The mu of sample A equals the mu of sample B. The alternate hypothesis is that the mu of sample A does not equal the mu of sample B, recalling that mu is population mean. Probability or significance level, P is chosen as less than 0.05. The degree of freedom equals 18. There are 10 minus 1 white male rats in diet A group, and there are 10 minus 1 in diet B group. The t-test with the degrees of freedom of 18 will equal negative 2.67 with a probability equaling 0.038. Thus, we reject the null hypothesis and we accept the alternate hypothesis that the mu of A does not equal the mu of B. Diet A rats had a mean sample weight gain of 5 pounds. Diet B rats had a mean weight gain of 8 pounds. The difference is considered statistically significant. The paired samples t-test, also called the t-test for related samples. This test can be used with two groups of individuals who are matched, or with a single group of individuals who receive both treatments at different times. Some examples include students' scores on one quiz compared to the same students' scores on a second quiz, or subjects' anxiety scores after treatment A as compared to the same subjects' scores after treatment B, or, as in the slide, preoperative pain scores versus postoperative pain scores in a sample of knee replacement patients. Recall that the paired or related samples t-test may involve either one of the following samples. First, two samples matched on variables known to be intervening variables, or one sample, that is, the same subjects paired with themselves. Thus, there are no intervening variables. The one sample t-test is designed to test whether the mean of a distribution differs significantly from some preset value. For example, does a course offered to college seniors result in a GRE score greater than or equal to 1200? Or a teacher wants to show that a new teaching method for pupils struggling to learn English grammar can improve their grammar skills to the national average. The sample would be pupils who receive the new teaching method, and the population mean would be the national average score. Analysis of variance is a procedure that compares data between two or more groups or conditions to determine the presence of differences between those groups on some continuous, dependent, or outcome variable. Please note that the t-test compares two distributions, while the analysis of variance, or referred to as ANOVA, compares many distributions. For example, we would use the t-test to answer the question, did male students score statistically significantly higher than female students on a final exam? Versus, we would use the ANOVA to address the question, did any of 5 different racial groups score statistically significantly different scores on a final exam? The ANOVA computes the capital letter F, uppercase, value. The Chaffee test would then be used to determine differences between groups. This test would determine which groups had statistically significant difference. Here is an example of a one-way analysis of variance. Using the one independent variable, race, a researcher wants to explore differences on a continuous variable, quiz score. the independent variable has 4 values: American Indian, Asian, Black, and White. A one-way analysis of variance will generate a significance value indicating whether there are statistically significant differences within the comparisons being made. This significance value does not indicate where the difference is or what the differences are, but a Chaffee test can identify which groups differ significantly from each other. The one-way analysis of variance uses degrees of freedom for the between groups as n, the number of groups, minus 1. The degrees of freedom for the within groups as degrees of freedom equals total number in all groups minus the number of groups. The statistic generated is uppercase letter F, as indicated previously. In our previous example, do the 4 racial group scores on a quiz differ statistically significantly from each other? In this example, F statistic with degrees of freedom 3 equals 2.272 with a probability equaling 0.045. This F at the p-value of 0.045 indicates a statistically significant difference between the 4 racial groups on the exam. Post hoc analyses, particularly the Chaffee test, are needed to determine differences among the groups. There are several post hoc analyses that can be employed with ANOVA. One is the least significant difference test, LSD, that is the most liberal of the post hoc analysis. It is simply a series of t-tests. The Chaffee and Bonferroni tests are the most conservative tests that can be used to see where the differences exist between the groups. The Tukey and the honestly significant difference tests calculate a number that represents the minimum difference between mean values to identify a statistically significant difference. This slide is a snapshot of an SPSS screen under the one-way ANOVA icon. This presentation was prepared for graduate nursing students at Drexel University College of Nursing and Health Professions. The primary book used in this research course is The Practice of Nursing Research, Appraisal, Synthesis, and Generation of Evidence, 2017 edition, by Jennifer R. Gray, Susan K. Grove, and Suzanne Sutherland. This book is published by Elsevier Saunders, St. Louis, Missouri.